Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2135, indicates an issue with the throttle position TP sensor AB when the voltage correlation between the two sensors is incorrect. In the Honda Odyssey models from 2011 to 2017, this code often signifies that the electronic throttle control system may not be functioning as intended. The throttle position sensor is critical as it informs the engine control module, ECM, of the position of the throttle plate, which regulates air intake into the engine. The TP sensors work in coordination to provide a redundant signal, ensuring accurate throttle control. If there's a discrepancy, it can trigger warnings or performance issues in the vehicle. Understanding this code is essential for effective diagnosis and repair to maintain vehicle performance and safety. The DTC P2135 involves the throttle position TP sensor A and B, which synthesize a voltage signal that determines the position of the throttle plate. This system is essential for the accurate functioning of the vehicle's engine performance and responses. The sensors are located on the throttle body housing, where they directly monitor the movement of the throttle plate as it's activated by the driver's accelerator input. Their role is not only to provide real-time data to the engine control module, ECM, but also to ensure the safety of the vehicle by eliminating single points of failure. If either sensor fails or provides incorrect voltage readings, the ECM may receive contradictory data, leading to reduced engine performance or even safety issues. Hence, accurate function and tested integrity of these sensors are critical before performing further troubleshooting steps. Several factors can cause the DTC P2135 to trigger. First, faulty throttle position TP sensors A or B, which may have mechanical or electrical defects, can lead to an incorrect voltage correlation. These sensors should be the first area inspected during diagnostics, as malfunctioning sensors provide unreliable data to the engine control module, ECM. Second, poor wiring connections can interrupt the transfer of signals from the sensors to the ECM, leading to intermittent or incorrect readings. It's essential to inspect the wiring harness for frays, shorts, or loose connections. Lastly, a faulty powertrain control module, PCM, which interprets the signals from the sensors, could be contributing to the issue. If the PCM itself is not functioning correctly, it might misinterpret or fail to accurately utilize the data from the sensors. Each of these factors plays a significant role in the performance of the vehicle's throttle control system. When the DTC P2135 is present, drivers may experience a range of symptoms that indicate underlying problems. One common symptom is reduced engine performance, where the vehicle may hesitate, stumble, or lack acceleration response due to throttle limitations. This occurs because the vehicle's PCM is trying to protect the engine from potential damage by limiting throttle response. Throttle control issues can manifest in the form of erratic engine behavior or instability in maintaining speed. Additionally, warning lights on the dashboard may illuminate, particularly the check engine light, CEL, alerting the driver to an issue that needs attention. Given these symptoms, it is critical for users and technicians to take notice and act promptly to resolve the problem, ensuring safe and effective vehicle operation. The first step in troubleshooting DTC P2135 is to turn the ignition switch to the on position. This action powers the vehicle's electrical systems, enabling diagnostic tools. It is crucial to record any freeze-frame data available, which provides valuable insight into the vehicle's behavior at the time the fault occurred. This information may include engine speed, throttle position at the time of failure, and other operating parameters. Furthermore, reviewing the general troubleshooting information is critical to understanding the specific tests needed to diagnose the TP sensors and associated systems accurately. Resetting your focus here will help ensure that subsequent steps in the diagnosis process are executed efficiently, safeguarding against overlooking any crucial data or procedures. Next, it's recommended to use the Honda Diagnostic System, HDS, to clear the DTC. This system allows for clear diagnostics and troubleshooting management, specifically tailored for Honda vehicles. Clearing the DTC will help reset the system, clearing any erroneous fault codes that may have been previously logged. After clearing, it prepares the vehicle for fresh testing, which ensures that the subsequent codes are indicative of current conditions. Removing the fault codes allows any intermittent issues to surface without the historical errors clouding the diagnostics. It's important to follow this step diligently to obtain accurate readings and proceed with confidence in diagnosing the throttle position sensor issues. The next step involves performing the Electronic Throttle Control System, ETCS, test using the HDS. This test is critical to assess the electronic throttle system's functionality. The selection of the test within the inspection menu of the HDS allows technicians to monitor live data from the throttle system, giving insight into the operational status of both TP sensors and their responses. Evaluating throttle operation during this test will reveal any inconsistencies or discrepancies that might indicate malfunctioning components. It is essential to observe the behavior of the throttle valve as it interacts with different input signals. A thorough comprehension of the outputs during this step sheds light on potential issues within the system, guiding further troubleshooting. After conducting the ETCS test, the next step is to check for any pending or confirmed DTCs using the HDS. This step ensures that not only the P2135 code is still active, but also helps identify any other related issues that may affect the throttle operation. Analyzing the status of pending DTCs provides a broader view of the vehicle's condition and flags other potential problems that may require attention. If DTC P2135 is indicated again, it confirms a persistent issue with the throttle position sensors. However, if no codes appear, it is likely an intermittent failure, suggesting that the current system appears functional at that time. This highlights the importance of reiterating through inspections of electrical connections and terminal integrity for a comprehensive diagnosis. Once the preceding tests have been executed, the technician will turn the ignition switch to the lock 0 position to ensure all electrical systems are powered down, thus allowing safe handling of components. Following this, the intake air duct should be carefully disconnected from the throttle body. This step is crucial as it provides direct access to the throttle valve for visual inspections and operational checks. It's important to handle this component with care to avoid damaging any seals or internal components. Disconnecting the duct will also ensure that any airflow-related issues do not interfere with assessments of the throttle operation. Preparing thoroughly for this process sets the stage for an accurate evaluation in the following steps. With the intake air duct removed, the next step is to turn the ignition switch to the on-2 position again. This will power the electrical systems, allowing real-time monitoring of the throttle valve's operation. While using the HDS, the technician should visually check the operation of the throttle valve. The objective here is to observe if the throttle valve moves to its fully closed position temporarily, as indicated by the HDS. Clearing the DTC while observing this behavior will help confirm whether the throttle valve is responding correctly to the signal sent by the sensors. If it operates as expected, it indicates that sensor and valve functionality is likely intact. leading towards the next stages of troubleshooting. However, any irregularities should bring attention to possible faults requiring further investigation. After checking throttle operation, turn the ignition switch back to the lock 0 position for safety. The next significant step is to jump the SCS service check signal line using the HDS. The SCS line jump is necessary because it prevents the PCM from entering diagnostic mode and allows the technician to conduct further checks without interruption. This step is critical for accurate data collection during the diagnostic process. Following this, the technician will disconnect the PCM connector B with 49 pins to access critical wiring paths for checks. This disconnection prepares for continuity testing of essential terminals in the following steps, ensuring thorough assessment of all potential faults in the electrical system involved with the P2135 code. The final troubleshooting step involves checking for continuity between specific terminals of the PCM connector B, where terminal B17 and B26 correspond to the throttle position sensors. The continuity test is designed to evaluate if there is an uninterrupted electrical path from the sensors to the PCM. A successful test would indicate that the wiring leading to the PCM is intact, while any lack of continuity would suggest wiring issues, such as shorts or disconnections that require repair. Ensuring the integrity of this wiring is crucial, since poor connections can lead to intermittent failures, worsening the throttle performance. This final evaluation in the diagnostic process is vital to eradicate potential electrical issues that may affect throttle control, leading to P2135. For a successful repair, it is essential to conduct a final verification process. Begin by rechecking all connections to ensure that any repaired or replaced components are secured and free from debris or corrosion. After confirming these connections are tight, a test drive should be performed under various conditions to monitor engine and throttle performance. This will help verify that the systems are functioning correctly without triggering the DTC P2135 again. Additionally, after the test drive, use the HDS to confirm that the DTC is no longer present, indicating the issue has been resolved. This series of checks guarantees that repairs made address the actual fault, ensuring the vehicle operates safely and reliably. To prevent the recurrence of issues associated with DTC P2135, regular preventative maintenance is crucial. Scheduling periodic inspections can help catch potential problems early, ensuring that all components, including sensors and wiring harnesses, are in optimal condition. Regularly checking the throttle operation can help detect any irregular behavior before they escalate into serious issues. Additionally, it is vital to clean electrical connections periodically to prevent corrosion and enhance conductivity. Such upkeep can greatly extend the longevity of the vehicle's throttle control system and improve overall vehicle responsiveness. Implementing a consistent maintenance schedule helps preserve performance and safety. In conclusion, the DTC P2135 and the Honda Odyssey models from 2011 to 2017 underscores the importance of accurate throttle position sensor readings for efficient engine performance. Understanding the implications of this code is crucial for effective troubleshooting and repair. Following a systematic approach to diagnostics will allow for accurate identification and resolution of failures within the throttle control system. Moreover, adhering to preventive maintenance practices will equip vehicle owners to mitigate risks of such issues recurring in the future. Ultimately, thorough diagnostics, repairs, and proactive maintenance plays a key role in ensuring safe, reliable, and optimal performance of the Honda Odyssey. Please like and subscribe to the channel. See you next time.